All right, everybody. Hey, how's it going? My name is Sebastian Mayak, and thank you kind of for joining me for this workshop. Um, so what we're going to really do is have the capability of orchestrating a FortiGate firewall and introduce. I'm going to paste the link here. This is the link of a guide that you can deploy this on your own. And this will kind of allow you to do really whatever you want to in your own environment to play around with this itself. So why don't we kind of get started on what we're going to do. And let me just show the guide here so you can kind of everybody can see it on how this is going to look like. All right, awesome. So that link is sent to us, and here's what we're really going to do. So we're going to be deploying FortiGate VM. And this FortiGate VM is going to be deployed inside of AWS with a gateway load balancer that integrates into kind of this robust, focused network infrastructure within an AWS cloud environment. We're going to be utilizing FortiGate VM, which is a virtual firewall solution from Fortinet that has the capability of doing a bring your own license or pay as you go model itself. And really by integrating this AWS gateway, this kind of setup really enhances network traffic management and security perspective across both public and private subnets in a secure VPC. So if we take a look at the image here, let me blow this up a little bit. So this is pretty straightforward. We have an AWS VPC in here. We are going to build two AZs, so availability zones. We're going to create a secure VPC subnet in here for us. And we're going to, inside the secure subnet, create a gateway load balancer that's going to be load balancing our FortiGate firewall. So as traffic comes in through the internet gateway through AWS, it's all going to be routed to our secure VPC. And this secure VPC is going to be able to help us route that traffic and really configure it and move forward itself. So what we're going to use in this is we're going to use things as Terraform, so for infrastructure as code. We're going to use GitHub Actions to orchestrate our pipeline, and of course, AWS itself. So let's kind of get started in here. Let me just make this bigger. So just a quick thing. The AWS Gateway Load Balancer is a networking feature really that kind of simplifies the way we deploy, scale, and manage virtual appliances, kind of like the firewalls we're about to do, or any intrusion detection systems or prevention systems in the cloud. It really provides a couple features as simplified traffic distribution, high availability, scalability, consistent data path, so the entire data path is the same, and integration with other cloud services for kind of enhanced monitoring, security, and analytics itself. To deploy this infrastructure, to deploy these VPCs, so two customer VPC, a FortiGate VPC, FortiGate VM instance, and our application, we're going to use Terraform. And Terraform is an open source infrastructure as code tool really created by HashiCorp, and it allows users to define, provision a data center, infrastructure, really using the HashiCorp configuration language, or HCL. Terraform is great because it enables us to define and manage complete infrastructure life cycles in a declarative way using code. It's cloud agnostic, so it supports multiple service providers, immutable infrastructure, has a state management. So Terraform maintains a state file, which keeps track of all the resources it manages. Really, this allows us to map real level resources to our configuration. It's modular, so it allows us to encapsulate and reuse code, which we'll be doing in this kind of exercise. Allows us for change automation, orchestration, and collaborate within a workflow to deploy, a CI/CD type pipeline workflow. What we're going to do with GitHub here itself. Then in that, we're going to be using GitHub Actions. GitHub Actions is a continuous integrator, and it is a continuous integration and continuous delivery platform. So our CI/CD platform that will allow us to automate our builds, our tests, our deployment pipeline directly within the GitHub repository itself. It provides that automated workflow, customization. We can have runners being hosted or self-hosted, allows us to integrate with many different GitHub features, provides a whole secret and environment management system, live logging results, tons of options for us. And it really kind of just simplifies the process of automating our workflows. And I find it makes it easier to build, test, deploy code or infrastructure within that GitHub repository itself. So if we dive in, I pasted in the kind of the Gitbooks guide that I deployed. Just a heads up, there are prerequisites that you'll require to get this deployed. You'll need an AWS account. You'll need an AWS CLI installed. You'll need GitHub, Visual Code, a GitHub account. And lastly, you'll need to subscribe to the FortiGate. Here's the link below. But when you do go through this lab and you do deploy it the first time, you might get an error if you haven't subscribed to the actual instance. And this will allow you to be able to use that instance itself. There's a link in here for AWS free trial. Definitely use that to set it up from a cost perspective, just to save yourself some money if you're kind of playing around in the environment itself. So if we get started with the actual environment, let's kind of jump into the deployment. So you can follow this guide step by step to really get everything kind of set up for yourself. So if I share, this is my visual code. I just have a working directory in here. I'll make this a little bit bigger so we can see. I already set up my AWS links and resources and my configuration. So I already ran the config to be able to deploy or configure my AWS and my GitHub repo into it. I did add steps in here just from a time perspective. We will skip that. But if let's take a quick look at it actually. Making one adjustment here. Go. All right, perfect. So let's take a look. And so first thing we have to do, we have to set up AWS. So to set up AWS, you can either, if you're using a Mac or a Linux machine, you can export your AWS keys and access keys in here. These are not real. These are just fake, just an FYI. itself. Then you can set up your VS Code, or you can run AWS configure to configure your environment to be able to connect to your AWS cloud itself. Next step, we have to set up Visual Code. So you can configure GitHub manually using the following commands: git config username and email, or you can use Visual Code Authenticator that you can authenticate to Visual Code. That's what I'm using. It makes it easy for me to authenticate to my GitHub repo itself. So the first thing we have to do when we build this infrastructure is we have to create our Terraform state. That's the most important part, because we don't want to store the state file, which is going to have all the information about our infrastructure. If someone can't get the link, just paste it again. We're going to have all the information in here. Post it on this way, and I'll post it in the LinkedIn chat here. So first thing we're going to do is create that Terraform state, right? We're going to store the entire state in an S3 bucket. So let's do that. So first step in our configuration, I've created a Git repo that really has the configuration for us. So we can just do git clone, make this a little bigger. When git clone the repo, that kind of shows us how to build the S3 state. We're going to jump in that working directory. And the first thing we're going to do with Terraform is we're going to do Terraform init. And this command allows us to initialize Terraform itself in this working directory. So we'll go Terraform init. So now what it's doing, it's going to download all the providers. It's going to initialize really the backend for us in here. Next, we want to do is do Terraform plan. So the purpose of Terraform plan command is used to create an execution plan, really a dry run for us to see, to make sure that all the code we have in here is correct. And when we take a look at this configuration, we see that it's going to build an S3 bucket for us. It's going to store that state in there. It's going to create a DynamoDB database to store our configuration, and our S3 bucket to store the configuration. So since it looks all good, we're going to click on Terraform apply. We're going to press yes to execute the configuration. And let me share that link that was not showing in here. Once again, I'm going to paste it inside of the events. So hopefully you got access to the links. I just pasted it inside of LinkedIn. So now that we've deployed our configuration, what we get is this output, and that has our bucket, our DynamoDB table, and really our S3 key kind of to be able to populate any type of infrastructure we put into the cloud itself. So let me just log into my AWS console here. So we can see that, I'm just going to move this over here. we can see that my Terraform state here was created successfully itself. So the next thing we want to do, since we have this state, we can now go ahead and deploy the infrastructure. And to deploy the infrastructure, we have to do a couple steps ahead of time to be able to fork the code that I've already pre-built for this workshop to be able to kind of move things a little bit quicker along. So what we're going to do is we're going to get out of this directory and go back into our root directory. We're going to go to fork our configuration. So we're going to hit this repo link. We're just going to click on fork, and I'm going to install it in my own private GitHub repo here. So we'll create a fork. Somehow this thing is not showing in the comments. We'll figure this out why it's not going. If not, I'll share it out to the team. All right, well, I'll share that out. I'll share that out to the. I'll go through this and then share it out why it's not showing up. So in here, we're going to fork this repo. So I just did that. Now it's in my own private GitHub repo itself. I'm going to create that fork of the environment. There's something to do with the comments that it's affecting it, but I'll just paste it inside of into it, and I'll just share it on my LinkedIn post here, so anybody can kind of go take a look at it. So let's just continue with this. So we forked this repo. Now I have it inside my own GitHub itself, which is great. What I want to do is now create some GitHub secrets. And what we want to do is, because we're going to be letting GitHub Actions orchestrate all the settings and all the configuration, what we want to do is, inside of our GitHub secrets, we want to be able to add the specific keys that we want. So we want to be able to go to settings. We want to go to actions here. We want to click on new secret. And this is where we are going to be putting in some of our configuration. So our access key is going to go in here. And our secrets key is going to go in there itself. So we'll do our access key ID, and then we'll do our access secret key itself. And this will allow GitHub Actions to be able to connect to our AWS environment. So if I refresh the page, you'll see that my secrets are inside of my repository here. And that's great. So next thing we want to do is we want to jump back into our visual code editor and we'll do a git clone on our repository. So I'm going to do git clone, and here's my repository that I just forked. So we got SebiCorp right here. So if we expand this, we have a new working directory called Workshop FortiGate AWS Infrastructure, and there's a lot of Terraform code in here. If we take a look at the main configuration, I have some stuff uncommented for future deployment, but because the first thing we have to do is deploy the AWS infrastructure, so we have to deploy the VPCs, we have to deploy the subnets, we have to deploy the FortiGate device. We need that state or that infrastructure built before we can apply any type of application configurations or even manage a FortiGate firewall itself. So inside the infrastructure, we have a module called infrastructure that is going to deploy our FortiGate device, and it's going to bootstrap it off this configuration file. So really, we're just creating a VDOM. We're creating, setting the IP addresses that are going to be dynamically given to us by AWS. We're going to create the FortiGate instance. In here, we're going to create the subnets, the network interfaces, all the real information that is required, licensing, endpoints, keys, volumes for this deployment in here. And this is a typical FortiGate Terraform config. You can grab this off their GitHub page to really follow the FortiGate best practices itself. So once we have created that, what we want to do is we want to create a new branch, because we don't want to edit configurations directly right away on it. So we want to create a new branch in here. So what we're going to do inside of our CLI or inside of Visual Code, let's jump into the Workshop FortiGate AWS infrastructure, and we're going to do a git branch, and we're going to call this initial build because it's our first initial build itself. Once created this new branch, we're going to switch to the branch. So you can see on the bottom left-hand corner, we have main. What we're going to do is just do git switch initial build. So now we've switched it, and it takes a couple seconds, and it'll finally propagate on the bottom. As you can see, now we're in a new branch itself. And what we want to do before we Terraform apply this configuration, we want to make sure we edit the main.tf file and replace me with the S3 bucket that we've just deployed. So if you scroll up inside of your terminal, or if you've deleted it, you can actually click on the folder, go to the Terraform state, and you can see that here is my S3 bucket that I created. So I'm just going to copy this. I'm going to go back to my main.tf, and I'm simply just going to do a control find replace, because I need to replace this in 3 different locations. So what this does is it's going to use the backend for Terraform. The backend is going to be S3, and here's the bucket information of my S3 environment in here. So I'm going to save this config. In here, the next thing I have in here is my GitHub workflow. So this GitHub workflow is what's going to get initiated by GitHub Actions to be able to orchestrate and push the configuration. And this is a pretty basic workflow deployment, but what it's going to do is once we've pushed things to the main branch, we're going to install Terraform inside of this container or inside of this GitHub Actions runner. We're going to perform a Terraform init, our Terraform plan, our Terraform apply to deploy the configuration inside the environment. So since we've done this, we're going to git add all our files. We're going to git commit initial build into our repo. Then we're going to git push set upstream origin to the initial build branch. So now this uploads all the information into GitHub, and we can jump right into GitHub and we'll see what happened here. So I go into my repo and it says, all right, cool, you created a new branch. Are you ready to compare and pull that request? So before we do that, the first thing we have to do, because we haven't enabled actions in here, is we have to click on the actions tab and I understand my workflow and go ahead and enable. Pretty simple. Now that my Terraform actions is enabled, I can go back to my repository and then I can click on compare and do a pull request on here. One thing note, we want to change this to our repository. In here, we can have a set of reviewers. We can have different people assigned labels, projects, milestones. So if you're working in a larger team that is managing your infrastructure, you're going to have some set of reviewers applied to here that like somebody has to review this code, and you can have, and if they review it, they approve it, then we can move forward with merging, comparing, and building the configuration. So let's create this pull request. So we're going from the initial build to the main base. So now we're going to see that we can click on merge that pull request. We're going to click on confirm. And we can take a look inside of now our GitHub Actions that it's going to perform all the Terraform configurations we want it to. So we can see that, it is in progress itself. So if we go to Actions, right, we can see the initial build is being deployed. And this is where Terraform action goes into place. So it follows, it installs Terraform, does the Terraform init that you'd normally do, creates the Terraform plan, so the configuration that is being deployed in our environment. And then it does the Terraform apply, where it applies the configuration itself. The deployment of any VM or any device does take time, especially an appliance like a FortiGate device. So it does take about 5 to 10 minutes to deploy this AWS instance. And if we take a look inside of our AWS environment, we can see that, all right, it created a couple VPCs for us already, created all the subnets, all the private subnets, all the routing tables, all the internet gateways that are required. And it's in the process of building out our load balancer, which is the gateway load balancer right here. It's still being provisioned. Once that's done, it's going to start building out the instance itself. So if we expand this, we can see at what process it is, and it's creating that load balancing gateway now. Once that's done, it's going to go ahead and build the actual deployment of this FortiGate device. So as this gets deployed, we can kind of take a look at some of the configuration in here that we're going to do next. So for me to deploy any of this Terraform code, really I'm just using the Terraform provider. We can simply just go to FortiGate FortiGate Terraform provider. And this provider gives us all the information that we need to know and understand how to manage a FortiGate device or a FortiOS device itself. Right now, I am just managing the FortiGate standalone firewall, but you have the capability of managing the actual manager of managing multiple firewalls. So it all depends on the environment you're going to build, and you have the flexibility to do it. To connect Terraform to a FortiGate device, what we have to do is we have to get the provider. So required provider has to be installed. What we're going to do in the next step. We need the provider configuration, so the host name, the token, and we can create a CA cert for it also. And then from there, we can then apply the different types of configuration. The nice thing about this provider is that, or the nice thing about Terraform and the Terraform provider's website is you can find all the different types of configuration you want and examples all located in here. If you want to configure routing, access lists, BPF, BGP, you have all the information in here to be able to take this Terraform config and deploy it. So if you're running some type of multi-cloud security VPC across Azure or AWS, you can use the same code pretty much across the entire environment itself. So what we're going to be using is we're going to be building out the base configuration of this, and we're going to be creating two applications. One application is just called Juicebox. It's OWASP Top 10 Vulnerable Web App. It's a great app that I love using. And then another, just an Nginx little simple web app where we'll be using modules to deploy the configuration itself. So if we go back in here, so our gateway load balancer was created, perfect. Now it's creating the endpoints for us, excellent. And for us to be able to manage the FortiOS, we have to, once it's booted up, we have to actually log into the GUI and create an API token. That token is going to allow us, or allow Terraform to be able to make changes, orchestrate any kind of deployments against the device itself. And here's kind of the guide, and I put it inside of the work in my guide on how to make that happen. So let's take a look back. All right, perfect. So now our configuration is complete. We see the output, and inside of the output, we have a couple of things that come out for us. We have the VPC, the public IP address of the FortiGate device, just a load balancing private IP address, the password. So when we boot up our first and we bootstrap our FortiGate device, we need to create a password on it. And once we log into that device, it's going to ask us to really change the password itself. So this is probably still not going to work, but so we'll have to wait for a little bit. And the next part of this deployment is we're going to deploy the configuration. So once it's booted. So what we're going to do is we're going to uncomment our provider, which is that FortiGate provider in here. And then we're going to uncomment our provider information. So we have our host name, that's from that infrastructure module. We have our token that we're going to implement inside of GitHub secrets. And then we have our core configuration file. So if we jump into the core configuration file, it's pretty basic, nothing kind of difficult, but it really provides you with some of the things you need to be able to kind of move forward and create this infrastructure as code for the FortiGate device. The first thing we're going to do is we're going to simply create address groups. We're going to use the Terraform resource for the OS firewall address, and we're going to create a couple address groups with the appropriate parameters in it. So we're going to have our VPC subnet, we have our private subnet AZ2, and then because all the traffic now is going to be routed through our gateway load balancer into that FortiGate device, we need to create an outbound policy. So if we create a new instance, a new VM or new EC2 instance, and it needs to access the internet to download some type of packages, containers, we have to allow it to go out through the FortiGate device, because the FortiGate device is now going to do all our inspection in and out of the VPCs. And inside the policy, so we have our outgoing policy. We're doing it in a specific VDOM, so a virtual domain. Inside of our FortiGate, we specify the action accept, the type of inspection, the type of log, the name of this policy. We can create a schedule. We can do SSL inspection, the status. If we're going to be doing NAT, we're not NATing in this instance. And then we specify our destination interface, what services we're going to allow. So for example, I'm just allowing all services, but we can specify this to HTTP, SSH, or any custom services that can be built inside of FortiGate. We provide our destination address, so all, because we want all to go in. And then we have our source address, which is just a variable that's going to pull the information from this address group. So it's actually going to fill in this address group that was created in Terraform for us itself. So, and the configuration is quite simple. So we're just creating those two objects. Within the apps folder, we're doing a little bit more. We're going to create this Juicebox configuration. And Juicebox is really that vulnerable web app I said. We're just going to deploy an AWS instance in Juicebox. We're going to apply it the key, the subnet associated to it. This is just the script for it to install Juicebox itself. We're going to have our security groups in AWS to allow those connections. And then we're going to have our FortiGate configuration. So we're going to have our FortiGate address that is going to get dynamically generated. So this will create an address group or an object with that AWS instance private IP address. Then it's going to create a policy inside of the FortiGate device that's going to allow inbound traffic to be able to hit that private IP address inside our device. And this will allow us to inspect it, apply any type of web policies, firewall policies, AV policies, DNS policies, whatever we want on the device itself. So let's take a look and see if our FortiGate has come up. Not yet. It takes about 5 to 10 minutes, to be honest, to spin this device up. Because we are booting a VM and we're kind of bootstrapping that deployment. Oh, there it is. So perfect. So now that we've connected to the device, because it's the first time we've deployed this device, there are a couple options or a couple pop-ups that come up. So I'm going to grab the password, which is just the ID number for now, and I'm going to paste it in here. First thing I have to do is change the password. So I'm going to put in my password and the default password. Oops, old password. So now I can log in with the new password I generated. So you're going to get a bunch of prompts because this is a new FortiGate device. There are a couple things that pop up. And yeah, this is recorded. It's going to be live on everything. So we're going to click on begin. We'll just click on don't show later and click on later because 7.4 has this automatic patching. It allows us to kind of create new features. We just click next and acknowledge this and just press OK to optimize the dashboard. Then we just click don't show. This is just a nice video that shows all the new features with the new FortiOS that we've installed on this, or we've booted this device up. So this is the GUI of the FortiGate device that we're going to manage. So right now we've deployed the entire configuration using Terraform. We can go to our network interfaces. We see that we have our private and public IP addresses configured inside that are, that are for that VPC that we've deployed. We have our VDOM created, so that virtual domain that's where we're gonna manage all the traffic. So in here we have our private interface. We don't have any firewall policies. Just use the new layout. We have no configuration on this device whatsoever because it is brand new. Everything's just implicit denied. So what we're going to do is we're going to create a REST API account or a token. So the first thing for us to create a token is we're going to create an admin profile. We can call this Terraform REST API. You can select what kind of access this API has. For this lab, I'm just going to set it to all to make it easy. I'm going to press OK. Once we've created this REST API, we're going to create a new REST API admin. So I'm just going to call this REST API admin. We're going to specify the virtual domains because you can deploy multiple virtual domains and have different teams and organizations manage that virtual domain. We have to create an administrative account for those specific domains. So I'm going to select FG traffic for our device. I'm going to remove the PKI group for this. And I'm going to select that profile, the administrative profile. It's called Terraform REST API. I'm going to press OK. So once this happens, this will generate a new API key for me. So we want to copy this and save this because we're going to be putting this inside of our Terraform secrets itself. So now that we've kind of gone through this login, this API, this information, let's go back to our Terraform code, or our GitHub actually. Just go all the way to the top. We're going to go to settings. We're going to go to secrets and actions, and we're going to create our new secret, and we're going to call this the FortiOS token. And this token is going to allow us to orchestrate changes towards this device itself. So now we have our 3 keys deployed in here. So the next step we want to do is we want to create the configuration inside of Terraform, or uncomment the config, and deploy it. But because we're using Git, first thing we want to do is create a new branch. So let's do git branch, deploy firewall config. Let's switch that branch. So now we're in this new branch for deployment. And we now have to edit some of our settings, some of the configuration. We want to uncomment some of the configs. So the first thing we want to uncomment is the main.tf. We want to install this new FortiNet provider, FortiOS provider. We want to set up the provider configuration, so the token that's going to be used and the host name. We want to uncomment these modules. These modules are just folders for configuring that firewall and configuring the application. In here, we also have things like depends on, because we want to make sure that the deploy and destroy eventually go in a specific order itself. So let's save these configurations. Let's edit the variables file and uncomment that FortiOS token. And then finally, what we're going to do is we're just going to edit this workflow. And in this workflow, we're going to add that variable into our deployments. So we're going to add the variable for the FortiOS token. So when Terraform initiates it, we're injecting the variable from secrets inside of GitHub. So we're going to do that for Terraform init, plan, and Terraform apply itself. Perfect. I'm going to save this information. Then we're going to git add. Then we're going to commit. So we're going to configure the firewall with base config. Configure firewall and apps. Then we're going to git push. So if you type git push, it's actually going to give you the actual command you want to put after. You can just copy paste git push, set upstream, origin, deploy firewall. So now it's pushed that request into our repository. And when we log in back, or we go back into our repo, we're going to see, all right, cool, there's a new pull request configured. So let's click on create new pull requests. We just want to make sure we merge it to our appropriate one here. We can set reviewers, assign people to review. I can set myself as an assignee that I have to review this. Definitely put notes, descriptions on what you're going to change. Let's create this pull request. You can add different branch rules in here. You can add a lot of different kind of, enterprise focused review assignee deployments, because in a production environment, you want other people to review your configs. So they'll be able to definitely go to the commit section, or go to checks, or go to changed files and understand, oh, what was changed? These were the following items that were changed in this configuration. And then you can go ahead and review, submit your review so you can approve it, request the changes to it. You can make comments, make this very, make it a very nice way for you to really manage this in this networking device, or this infrastructure as code. Is that? Yeah, Dave, this is being recorded. Self. So now it's in progress to apply the configuration. So if we take a look at our GitHub Actions, it performed the Terraform init, performed the Terraform plan. Now it's doing the Terraform apply. So if we take a look at the Terraform plan, oh, that went pretty quick here. All right, if we take a look at Terraform plan, it's giving us all the configurations that are going to be changed. The AWS EC2 instance called fake app is going to be deployed. The plus sign identifies that there's going to be an addition to it itself. The new security group is going to be deployed with the parameters. New application module for Juicebox is going to be deployed. A new firewall address objects are going to be deployed. Everything we have in that code now has been deployed, and it's been deployed successfully itself. So once we've done this, we can do a couple things. We can merge that pull request and confirm. And then because we're done with that branch, typically depends on the organization and who's in charge, but we can just delete that branch so we have that environment. And if we have to restore the branch and revert and back, we have restore branch, revert. So we have this capability of rolling back the configurations inside of our environment itself. So when we jump back into our FortiGate device, we didn't have any policies deployed. Now we can go to policies. Let's go to our FortiGate VDOM. We can go to policies. Takes a couple seconds to look. We see that we have 3 new policies deployed based on our Terraform code. We have our outbound rule that allows anybody inside of our VPCs to go out. We have our Juicebox policy that allows anybody from the internet to talk to our Juicebox application. We have the fake app, and the same concept, we have anybody that's able to talk to this fake application. So if we jump into our AWS environment, and let's click on refresh here. We can see that, all right, the FortiGate's up. Great, we have the 2 Juicebox servers, and they're still in initializing phase. So they're downloading whatever they need for them. So inside of this Terraform code, if I close this down, we built these apps in 2 different ways, actually. The first Juicebox application, we used, we built our own resource, and with using the FortiGate policies, so straight through just a resource for that policy, all the information, and the address group. So it's not long, but you're doing a couple lines of code in here. But we want to reduce this, so we want to create different modules, because we want the applications team to not worry about all these different options. We can define modules on how they can manage the security of their application alone within Terraform. So we can use things like external modules that are either hosted in Terraform Cloud or inside of your own public repos, and then eliminate all that code into 10 lines of code, for example. So in here, I have a module that you can click on the link here. I have a module that I've uploaded that allows me to reuse my FortiGate policies for any application. And inside this module, all I need to put in is what VDOM, the address name, the interfaces, the action, what's the IP, the policy name, and a lot of this stuff could be already pre-generated. You can already make this even smaller. The services that are allowed in here, and the configuration. So we can modularize all our firewall configs to 10 lines of code that other application teams can take and can reuse for other web applications itself. So let's see if our web app is online. We're just going to go back to AWS, and perfect, everything's online. So now we can actually hit the public IP address of Juice Shop. This is just a web application. There we go. And our app is online and it's working. And then if we go to our FortiGate device, we can see that, yeah, all right, cool. Let's refresh this. We can see traffic is hitting our interfaces and going towards our application. So then we can apply now more policies that are required to be able to either inspect, create different types of security profiles and policies for this. So even if you click on edit in here, so in editing here, you'll have the capability of adding more security profiles. The one thing to note is that if you use Terraform to manage the FortiGate device, use Terraform to manage the FortiGate device, because if a user applies a change manually to this interface, and then somebody creates a new policy or creates a new profile or object inside of FortiGate, Terraform is going to rerun that code, and its source of truth is going to be that Terraform state file. So it's going to overwrite your configuration. So really, this kind of moves the organization and the team forward to managing the entire FortiGate infrastructure through infrastructure as code. It makes it very easy not only to understand what was configured, in here, but it makes it easy for us to export this data to a monitoring tool, a logging tool. There's Terraform docs, Terraform graph that allows us to really draw the picture from an auditing perspective. So in the last application that we deployed in here was just a fake service app, just another, I think it's just an Nginx web application that just a little simple dinky website that gives us access and tells us where and what somebody connected to and connected from itself. So the process to get this working inside of a production, like this is inside of a production environment, is not too difficult. What things I would change in here for production ready, of course, logging, monitoring, make that FortiGate firewall with auto scaling, so it goes up and down and high availability itself. Inside of GitHub, create ownership and reviews and assignees, so create some branch rules that will allow us to, and allow the team that on how we manage these updates, to make sure that not everybody can go in. There has to be a subset of reviewers, assignees, and approvers to be able to push the configuration. But in the end, what this does for the organization, it literally creates a state config of the entire firewall. So if something happens and this blows up and this, the configuration is dead, we will have inside of our S3 bucket the state. So if I jump in here, we'll have the state of the entire configuration inside this JSON, inside of our Terraform state. So we know exactly what's there. And this is versioned. So we have older versions of the configuration. So we could always go back and edit, audit, and redeploy this configuration, because everything in here is done with Terraform itself. So with that, the final step in here is to be able to, destroy the environment. Because this is a lab, I don't want you to be build. What we want to do is destroy everything in here. So if everything's working is fine, play around with it, please. And what we're going to do is next is just do a Terraform destroy. So nobody gets charged for the cost of it. I think the cost is going to be like $5 or even less to run this environment inside your own AWS repo. So what we'll need to delete the environment, we'll log into the workshop directory. We'll log back into the FortiGate device. We're going to need that variable, or we're going to need that API token. I forgot to save it, but it's very easy to generate a new one. We go to global, system administrator, and generate new API key. Perfect. So then we can go into our working directory and do Terraform init. We can do two things. We can either change this variable up here and do default and put in our token, save that config, and do Terraform destroy. And Terraform destroy is going to literally destroy that whole entire infrastructure we just built. So definitely fork this repo if you want to learn more about Terraform, FortiGate, and GitHub Actions. But it allows you to, for a minimum cost, I think it's $1 per hour for the FortiGate device, to really kind of play around and test it out. So we're going to say yes, we're going to destroy everything in here, and it's going to go ahead and destroy our environment itself. And after this gets destroyed, we'll do the same concept inside the S3 bucket, just so we have a clean, clear environment in here. So this video is going to be shared on my LinkedIn, my YouTube, and my Twitter. So please go ahead, and if you want to watch that recording, take a look at it. I will post again the guide inside of on LinkedIn and Twitter or X, so you can deploy this inside of your own environment however you want. So in the end, what we really did here is, so you can see the FortiGate device is already getting destroyed. The website's already not working. It's already down. So really what we did, it's pretty straightforward. We built a lot, but we did it very quickly. Within an hour, we built out an entire VPC in AWS. We set up the ingress routing tables, so all the traffic is sent within these AZs to the gateway load balancer itself. Then it's all routed to our secure VPC, where we host our FortiGate device to perform our inspection, our IDP, all our firewall deployments in one location. And then we deployed two set of applications across two AZs that we allowed access to. So as traffic went into these applications and connected, we were able to inspect the data on our FortiGate device and create those security kind of policies that we have using Terraform for that infrastructure as code, immutable infrastructure, and also using GitHub Actions to be able to orchestrate those deployments and create this workflow that we really want itself. Thanks, Ali. So perfect, 57 objects have been deleted, so my entire AWS infrastructure is gone, and we can go to Workshop S3 if we want. We can Terraform init, and then Terraform destroy our S3 bucket, so we have a clean configuration itself. Yes, perfect. So with that, here's the link. I'll share the link again. I'll share this video for anybody that wants to see it. I really appreciate everybody joining me for the hour. Feel free, if you have any questions, send me any questions on either X or on LinkedIn or YouTube. This video is going to be posted, and appreciate everybody joining. Thank you very much.